Hello guys, welcome to my channel. This is C# based design pattern course, and today's tutorial is about implementation of abstract factory. I am hopeful you are enjoying my videos and learning programming. If you have not already subscribed to my channel, please subscribe and promote the content. Intent of abstract factory design pattern. This is a creational design pattern. This design pattern provides a top-level interface to expose creation functions, and this common interface is to create objects of related or dependent classes. The motivation behind this design pattern. Consider a company payroll. This design pattern can be implemented in any kind of environment where we need to create or use related or dependent objects. So in a company payroll system, we used to encounter different types of employees. These different type of employees can be salaried, can be commission based, can be hourly workers, and can be commission plus base employees, or can be any other type, contract workers also. It provides an abstract employee factory. This abstract employee factory interface is to create different types of objects of the employee classes. Employee creation is transparent from the client code. The client code does not directly create different types of employees. It uses instance of abstract factory and uses its functions to create the objects. The consequences or implications of this design pattern. It isolates concrete classes and controls the object creation. Abstract employee factory is responsible for creating different types of employees. Abstract factory implements a singleton design pattern, as there is only one factory instance needed to create related or dependent objects. So we will also incorporate a singleton design pattern to create the abstract factory object, so that throughout the application there is only single instance of the factory object available to create different employee types. The major disadvantage is that it is difficult to extend the abstract employee factory to add more types, because we have to add couple of more classes and also change the interface and the concrete class. So this is a lot of hassle or overhead to extend this design pattern to add more entities or more types of the related objects. This is the flaw in this design pattern. Participants. Abstract employee factory. This is top level factory interface that will expose functions to create different types of employees. Employee factory. This is concrete class that will implement the abstract employee factory interface and provides the implementation of the creation functions. Abstract employee. This is top level employee interface. All the subtypes are special classes for the employees. For example, commission employee, hourly employee, etc. will be implementing this abstract employee interface. Employee class. These classes are salaried employee, commission employee, hourly employee, base commission employee, and you can add further classes according to your need. For example, contract based employee or any other designated employees. Client code. The client application uses abstract factory interface and employee factory object that will be implementing singleton design pattern and uses its functions to create different types of employees, and it does not bother or directly interact with the child classes of employee. This is class diagram. This class diagram defines or represents the implementation of different classes and interfaces in the abstract factory method. There are two top level interfaces, employee factory. This interface provides the functionality for abstract factory design pattern, and it is implemented by employee factory that will create each of the 4 employee objects. These concrete classes implement employee interface to provide a global representation. So this employee interface is used here, not these classes. So this factory is transparent to these objects. Each function is associated with one of these classes, and when they are called, these objects will be created. Thank you guys. Let's implement the abstract factory design pattern using C# programming. Thank you. Hello guys. Let's implement abstract factory design pattern. I have created an application in Visual Studio 2022, and I have added the interfaces and the classes we need to implement the abstract factory design pattern. So let's check the file that I have created. So at top of it, I have created an employee interface. This interface will define a salary function that the subclasses or specialized classes implementing employee will implement. So those classes are salaried employee, and then I have hourly employee and commission employee and base commission employee. These are 4 child classes that will implement employee interface. Then the abstract factory method, that is employee factory. This is top level employee factory interface. The employee factory class will be a concrete class that will implement this employee factory interface and provide 4 functions that will create one specialized employee object. And then the program, this is client code that will use the employee factory interface and create the employees and display the salary and the employee information. So let's begin with the employee interface. So public, and let's say double salary. Let's capitalize this one, salary. Function to calculate the salary of the employee. So let's change the access, because internal access requires it does not declared here. So double salary. So next, this interface will be the top interface for the employee objects. So all the employee classes will implement this one, employee. Okay, let's copy this. Okay, currently let's return 0, just a stub. So let's implement the same function for the other employee classes. Hourly employee implements employee and implement the function. Commission employee extend employee and implement the function. Similarly, base commission employee implement employee and this one. Okay, now next we create a function, we create constructor for these classes. Salaried, let's say private double, and let's say wage. Public salaried employee double wage, and this dot wage is equal to wage. This constructor will create a salaried employee. Now let's override a toString method. Get the string representation of employee object. Okay, we return let's say we name it salary employee and salary. Okay, let's copy this and we put it into other employee classes. Base private double base salary, private double commission. So constructor public base commission double base salary and double commission. And this dot commission is equal to commission. Okay, oh, this is base and commission employee. So we calculate the salary. Constructor to create base commission employee object with the base salary and commission. Okay, now we need commission employee, private double commission, and constructor public commission employee double commission. Create a commission employee with the given commission. Okay, toString function we can copy paste and change it to commission employee, and salary remains the same. And next we need hourly employee. So private double and hourly wage and private double hours worked. I think go inside the class instead of namespace. So let's add constructor public hourly employee double, and that's it. Create hourly employee with hours worked and hourly rate. Okay, now copy toString function from here. Hourly employee. Now the salary functions. We need to implement salary function for each of the object. So this is our salaried employee. So we simply return the salary because that is the total salary of the employee. Okay, now base plus commission. So we return base salary plus commission. And next, commission employee, so there is only commission for his salary, so we return the commission. And next is hourly employee. So hourly employee, we need to calculate the wage. So double wage is equal to 0. So it is conditional. Number one, let's say double hours is equal to hours worked. So if they are above 40, increase wage 50%. So if hours greater than 40, so wage is equal to hours minus 40 and multiply by 1.5 multiply by hourly wage and reduce the hours by 40. So now calculate the rest of the regular pay. So wage plus is equal to hours and multiply by hourly wage. Okay, and at the end return total salary. Okay, now over employee classes are complete. We have implemented salary function for each of them and a toString function to get the representation of the employee and his salary, and every employee has implemented iEmployee interface. Now the factory design pattern. So we start with the iFactory. So to provide an interface, a common interface to create 4 different employee objects, we need 4 functions. So we need iEmployee, create, commission employee. So commission employee, we need to pass commission. Okay, function to create a commission based employee object. Next we need iEmployee and create, let's change the notation because it uses camel notation. Create hourly employee. So hourly employee need hours, hourly wage and double hours worked. Function to create an hourly employee. Okay, next we need to create a salaried employee. iEmployee, create salaried employee, double salary. Create an employee with salary. Okay, now base plus commission. iEmployee, create base, commission employee. So we need to pass base salary and commission. Create an employee with base salary and commission. So this is basically 4 basic interface methods that will create an individual employee depending on the type of employee, and we create the object from the child classes of iEmployee interface. So this global level factory method, abstract factory, will create or help us create these employees using these methods, and these methods will be implemented in the concrete factory class, that is employee factory class. So employee factory will implement the iEmployee factory interface and implement these functions. This class will also implement a singleton design pattern, and this class there will be a single instance of this class that is also maintained by this class itself, and outside of this class nobody can create object of employee factory. So public, and let's make these skeleton functions. Public, public. Basically this application is using two design patterns, singleton and abstract factory. Public. Okay, now let's implement the singleton first. So private employee factory, let's make it static. So there will be only a single instance of this object, factory. Okay, now constructor, private constructor, private employee factory. Okay. Restrict the object creation by declaring private constructor. Okay, now provide an access point, global access point, so that we can create the object. Instead of this, we need to add a function. Okay. Let's say get factory. Okay, now check if factory is null. If this dot not this, factory is equal to null, we created factory is equal to new employee factory, and we return it, return factory. This is singleton design pattern, and this will ensure that there is only a single instance created within the life cycle of this application. Provide a global access point to the singleton instance of this factory. So this is the perfect design adaptation for the single object, and we restrict the creation of this class object from outside of this class. So this class will maintain the instance of itself, and this is singleton design pattern. Now let's implement the abstract factory methods so that we can use this instance to create the employee objects. So this commission return new commission employee commission. There are another option or way to implement this. We can implement a single function to create an object and pass a parameter of type, what type of object we need to create, and based on that parameter we can create object. For example, we can pass an enum. The enum variable, we can identify which kind of object we require, but this strategy of implementing a single function to create a single object is far better than that one. This is more efficient and faster. Return new hourly employee. So hourly wage and hours worked. And next we create salaried employee. Return new salaried employee salary. And next we return base plus salary. Return new base commission employee and base salary and commission. Okay, these are our 4 functions to create 4 different type of employee objects, and our class concrete employee factory class is complete here. Now let's use this class to create objects. So let's go to client code. Here create instance of employee factory. So I employee factory is equal to employee factory dot get instance. So get factory. So singleton design pattern. Now create employees. So first let's say I employee is equal to factory dot create salaried employee. Let's say 25,000, and we can print it. emp dot toString. So this will print over employee. Now let's copy this line to save time. Okay, next 2, 3, 4 type of objects, and we can store on this. So number 1 created salaried employee. So now let's create hourly employee. Dot create hourly employee and pass, let's say 13.5, and it worked 42 hours. Okay, next create commission employee. Dot create commission employee. So let's say 19,000. Okay, next base plus commission. Dot create base commission employee. So base is, let's say 5,000, and commission is, let's say 12,900. Okay, so using single factory we have created 4 types of employees, and each call create a specific employee object, but we do not mention or refer to the class, our employee class, our subclasses. So this is how we implement an abstract factory design pattern that is responsible to create related or dependent classes of a family. So let's stop the console.read key. So let's run it to see the results. Something is wrong. Let me check what is wrong here. So the bug is this: instead of creating it inside the constructor, because this will result in Stack Overflow. So we creating it here. We just declare the default constructor here and do nothing. So let's run it. So these are our 4 employee objects: salaried employee and its salary, hourly employee, its salary, and commission employee, and the base commission employee.